Okay, in the last video, we were talking about one and two-step equations, and we were solving out, having to cancel out things like addition, subtraction, and then multiplication and division. Here, I want to talk about a couple other things. For one, there's a few properties that we should know for addition and multiplication. And sometimes, this is worth noting, sometimes these are what are called the field properties. Because it gets a little more advanced in what a mathematical field is. But so we have the commutative property, which just states that you can switch the order anytime that you are doing addition or doing multiplication. So what that means is if I have a statement like 2 plus 7, I can rewrite that as 7 plus 2, and it means the same thing. Okay, it's same thing for multiplication. I can do 3 times 9, or I can do 9 times 3. That's what's called the commutative property. We can see it in numbers, and we can see it over here in this table for algebra too. If I have a plus b, I can rewrite it as b plus a. Same thing. Same value, nothing's changed. I can do the same thing with, again, multiplication. I can do a times b, same thing as b times a. And that's called the commutative property. And that's just going to help us when we're kind of rearranging longer step equations. The associative property just states that if we're adding three values at the same time, we can either add the first two together and then add the last one, or we can add the last two together and then add the first one to that, and we get the same number. So again, it's done here using parentheses. I can do, if I'm adding 6 plus 8 plus 2, I can think of that as 6 plus 8, the solution to that, added to 2. Or I can do it as the solution of 8 plus 2, in parentheses, added to 6. And the same thing goes for multiplying. Another property of all numbers is called the distributive property. And if you look at it with actual numbers, it combines both multiplication and addition. So if we're multiplying a number times a set of parentheses, and in those parentheses we're adding, then we can multiply this first number here times this first number, as in this example, 3 times 4. And then we can also multiply that first number by the second number here, 3 times 8, and then take the sum of those two, and it's going to give us the same value. So what we do with the distributive property most of the time is if we're multiplying, let's say for example, if we're multiplying a value like, say we have 2x, and we want to multiply that times x plus 5. So when we have our parentheses like that, we want to distribute this value. So we have 2x, and I usually call them the little rainbow marks. You kind of make a little rainbow shape here. You multiply the 2x first times x, and then you multiply it again, the quantity times positive 5. So here we have 2x times x. That's going to give us 2, and then x times x gives you x squared. And then the second one, and make sure that you're following the sign of what comes right before the value. Here we have 2x times positive 5. So our value is going to be positive 5 times 2, or 2 times 5, which is 10. And then our x is just going to fall into place right here. So that's what's called the distributive property. Or we say if you see parentheses in a problem, you're going to have to first distribute. In other words, take that first value and then multiply it across twice. And we'll see a couple more examples of that in these problems. Moving on. For multi-step problems, so when you have more than 2 steps to cancel out, we want to do a few things. We want to make sure we distribute. So get rid of all your parentheses by multiplying through and distributing everything. Okay, distribute first. Then you want to combine like terms. And like terms are terms that end the same way. In other words, right here we have in this expression 4x minus 3x plus 2. The 4x and the 3x are what we call like terms. So we combine them together. We add them or subtract them with each other. This is 4 minus 3, and we keep the x. So that ends up being 4 minus 3 is positive 1. So I can write this as 1x. Or in algebra, a lot of times we leave out the 1 at the very front, and we just write it as x. So 1x, same thing as just saying x. Other just numbers off to the side are what normally we call constants. And if we have more than one constant, then we can add those and subtract those to each other. So, to give you an example of that, say we have this really long expression here, or it's an equation that we want to solve for x, right? You're saying, well, I don't know where to begin, right? So let's start by distributing. We have negative 3x plus 8 minus 2x plus, here we have 2 times, and it's being multiplied by the quantity in parentheses 2x minus 1. So we're actually going to be multiplying here twice. We're going to distribute this positive 2, and it's positive 2 because it's got a plus sign right before it. And we're going to multiply it times positive 2x, and then again times negative 1. And remember, when you're multiplying and when you're working with combining like terms, the sign is always whatever comes right before a value, right before a number, not afterwards. So let's start to simplify this. We have, let's rewrite this. We have negative 3x plus 8, right, minus 2x. And here we have positive 2 times 2x. That's plus, or positive 4x, plus 4x. Then we have positive 2 times negative 1. So positive 2 times negative 1 is negative 2. All right, and that's all equal to 1. Then we start combining our like terms. Let's see. Let me use a green here. So we want to combine all of our x's into 1. And we want to combine all of our numbers, our constant values, into 1. So here we have a minus 3x, a minus 2x, and a plus 4x. Okay, those are all like terms because they all end with x. Then we have positive 8 minus 2. So let's take care of our x's first. We have negative 3x minus 2x. So those two together give us negative 5x because we're just doing negative 3 minus 2. So negative 5x plus 4x. Actually, I don't want to skip steps, so let me rewrite that. Here we combine these two, right, as negative 3x minus 2x. So that's minus 5x. And then here I have, I still have this plus 4x. I haven't gotten rid of that yet, or haven't combined that yet. And now let's do our blue, the values that I underline here in blue. We have positive 8 minus 2. 8 minus 2, those are just constant values, so we can just add, subtract them left to right. Positive 8 minus 2 is positive 6 equals 1. And let's combine our like terms again. Here we've got negative 5x plus 4x. We combine those together, we add those together, positive and negative. So we have positive 5x, we have negative 5x plus 4x, and that gives me a minus, or negative 1. So negative x, negative 1x. Then we have plus 6 equals 1. And so now we've combined everything together. Then it just becomes a two-step equation. So just like we did before, we want to cancel out our addition and subtraction to get x by itself. We want to cancel out addition and subtraction. So we have plus 6 over to the side. Let's do minus 6 on both sides. That's going to leave you with negative x equals 1 minus 6, which gives you negative 5. we have here is really -1 times x. So we want to divide by -1 on both sides to get rid of that. And we have our solution x equals -5 divided by -1, which is +5. It's going to be the margins. So our solution, again, to this entire problem, multi-step, a lot of steps, is x equals +5. And again, we can check that. We can make sure that that's the correct answer by going back to our original problem and plugging it in, see if it makes sense. So what we're saying is that if you have -3 times 5, because that's where the x was, right, plus 8, minus 2 times 5, because that's where the x was, plus 2 multiplied by 2 times 5, I kind of ran out of room here, minus 1. If we plug in a 5 here, for every time we see x, then it should give us the value on the right, which is +1. And so you can go back and crunch all those numbers and just check and make sure that that is the correct solution, and it is. All right, you might also see an equation that has variables on both sides. So here's an example of that. If we have 7k equals 4k plus 15. So both sides of the equal sign have a k. But we want to still solve this out for k, and we can still do that. Using sort of the same steps, we want to collect all of our variables on one side, or in other words, combine our like terms, but make sure that we're doing them on both sides of the equal sign. And then make sure our numbers are on the other side, and then we're going to solve it out the same way that we've solved them so far. So let's take a look at that. Our first example here, 7k equals 4k plus 15. I want to collect all of the values that end with k to one side of the equation. So I can actually, I have a positive 4k on the right, so I can actually subtract 4k from the right-hand equation, which is going to cancel it out, and then also whatever I do to one side, I have to do to the other. So on the left, then we end up getting 7k minus 4k, which combines 7 minus 4 gives us 3. So we have 3k equals, this k got canceled, we don't have to write it on the right side anymore, but we do still have the positive 15 here, so that drops into place. So it ends up being 3k equals 15. We have 3 times our variable, so we want to cancel that out by dividing by 3 on both sides. And that's our last step. We have k equals 15 divided by 3, which is 5. Okay, now if we see it again, and again we have an equation here, we want to solve for x, and we have x's on the left side of the equal sign and on the right side of the equal sign. And it's really, you can actually do it either way. I can either, let me make a note here, I can either subtract 5x on the left, as long as whatever I do to the left side, I also do to the right side. Then it's going to balance out, and we can do that. We can combine our like terms. Or we can also do this. I can take away this 3x from, again, the left side and the right side. Either way, we choose to balance that, as long as whatever we do to one side, we do to the other. A lot of times people just don't want to deal with negative numbers that much. So we'll go ahead and do it this way. We'll take away, or we'll subtract 3x from the right and subtract 3x from the left. And in doing that, we'll be left right here with a positive 2x. If we do 5x minus 3x, 5 x's minus 3 x's ends up with positive 2 x's. And then the rest will fall into place. So minus 2 equals, that cancels, and we have positive 4 left on the right side. If we had done it with take away the 5x on left and right, it would have still worked. We would have still been able to do that. But it would have ended up being negative, a lot of negative numbers that we sometimes don't want to deal with. So here now we've got a two-step equation. We have 2x minus 2 equals 4. So add 2, cancel that out. We'll leave us with 2x on the left. On the right we have 4 plus 2, which is 6. One last step. We have 2 times x equals 6. So cancel it out. Divide by 2, divide by 2. So x is equal to 3. And then the same way that we've done the other problems, we can check our work by using this number, a number like 3 here, and plugging it back into our original equation. So let me go ahead and end this video by doing that. So let's take our original equation that we were solving, right? It said, 5 times some number minus 2 is equal to 3 times that same number, which we're calling x, plus 4. So we solved it out. We worked backwards, and we solved it out. We got x equals 3 as our solution, right? Oops. Let me get rid of that. And to check our work, sorry, I meant to highlight this. To check that and make sure that it's correct, we can go back and plug this in. So let's plug this 3 back into our original. So we have, instead of 5x, we have 5 times 3 minus 2. And that should be equal to 3, instead of 3x, it's 3 times 3 plus 4. So I take my original equation, I replace the x with the number 3, and I just want to do the math here and make sure that that works. So here I have, 5 times 3, it's 15 minus 2 equals 3 times 3 is 9 plus 4. 15 minus 2 is 13 on the left, 9 plus 4 is 13 on the right. So when I go back and check my work by plugging that number in, the x equals 3, then it does end up being a true statement. And again, anytime we solve an equation, we're claiming that that's the number that works if we were to plug it back in to our original one. So that's a good way that we can check every time.